So we talked about homeostasis, which is uh, the ability or the body's ability to maintain relatively stable conditions in the internal environment. Okay, and those conditions are based on a set point. So there's a set point for body temp. There's a set point for your blood pressure. There's a set point for your heart rate. So all things, your blood sugar, all of those things have a set point to them. And those set points are regulated or maintained through these mechanisms. Okay, so if we use body temperature as an example, so body temperature. So we'll just pretend that normal body temperature is indeed 98.6 degrees Fahrenheit. Okay, so your skin has little receptors in it, and these little receptors detect changes in temperature. Okay, so when your skin is too cold, okay, so let's say normal is 98.6. This is the set point. And let's say it starts to go down. Okay, you went outside, it's 2 degrees out, and your temperature is going down. So these receptors in your skin will respond to that. And they will send off a message, okay, to your brain, okay? So a message to the brain to say temperature's down, all right? So it does this through a pathway. And that pathway is a sensory pathway. Which makes sense. It's sensing that temperature is going down. We call that also an afferent pathway. Okay, so it sends that information down an afferent pathway to the central nervous system. Let's get another color, better one than that. There we go. And basically, this is the control center. And the control center is the central nervous system, which is basically the brain and spinal cord. This is where the input occurs. The sensory information goes into the control center, and it is integrated. So this is also in an integration center. So integration is where this information is now being compared to the set point. So this temperature that's now going down is lower than the set point. So since it's lower than the set point, then the control center makes a decision about what it's just learned from this sensory information that it got. And it will then figure out what to do, and it will send a response. Okay, so this is a motor pathway, also called an efferent pathway. So motor means we're doing something, okay? So we're sending the output, here's the output, down to something called an effector. And the effector will create the response. So in this case, if we are too cold, it's going to send the response information to skeletal muscle, and it's going to cause skeletal muscle to shiver, creating heat, heating the body back up. Okay, so this is going to happen, and you're going to shiver and warm up until we get back to the set point. Okay, you don't just keep shivering forever, right? So we get back to the set point here, and once the set point is achieved again, then this response shuts off. Okay, this is called negative feedback. Most bodily activity, homeostasis, is controlled through negative feedback, and all negative feedback maintains a set point. Okay? If we have negative feedback, probably have something also called positive feedback. And positive feedback enhances the stimulus. In negative feedback, we are lessening the stimulus. Okay, we got really cold, we're getting it back warmed up. Okay, so it does the opposite. It gets rid of that stimulus or makes it less. Positive feedback enhances that stimulus. So an example of positive feedback is childbirth, or more specifically, labor. So the stimulus in childbirth or labor is where the child's head starts to press and push on the cervix of mom. And when it presses, the head presses on that cervix, it causes the cervix to stretch. When that cervix stretches, it sends a sensory stimulus over a sensory pathway to the brain that says the cervix is being stretched. That causes the hypothalamus to release something called oxytocin, and that makes the uterus contract. So that stimulates the uterine muscles to contract. That further pushes the baby's head into the cervix, stretching it again. That sends a message back to the hypothalamus to secrete more oxytocin, which will go down to or target the uterine muscle, causing that to contract. That again will press the baby's head further into the cervix, making it stretch. That will send a message to the hypothalamus that will cause the hypothalamus to secrete more oxytocin. Oxytocin will go to the uterus, cause the uterus to contract again, and it will do that. And it will do that faster and faster and harder until baby is born. That is positive feedback. Okay, most homeostasis is controlled or maintained through negative feedback.